Alright, so we're going to go over Chapter 5, Section 5, proving triangles are congruent by side, 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 and HL, hypotenuse, leg. Now we're going to start for the warm-up. Please pause the video to give yourself time to work on this. Now, we realize that this triangle right here, it's an equilateral triangle, meaning all of its sides are congruent. Now, if we realize that all sides are congruent, all of these are equal to 40, and because right here, this one and this one are equal to 40, that means that this triangle is an isosceles. So X and that other tick mark are congruent. We can say that, for example, this 40 equals 8y divided by 8. We get that y is equal to 5. And then for X, we have to get this angle first, and we do 180 minus 60. And we get 120. We know we subtract 60 because those three angles are 60. So we say x plus 120 is equal to 180. 2x plus 120 equals 180. We do subtract 120 from both sides. And I get 2x is equal to 60. Divided by 2, divided by 2. And we get x is equal to 30. Now for this other triangle, we have all of these sides are congruent, and because this other triangle, this one right here, is congruent as well, we can say these two are congruent too. If you were to follow that these two are congruent and these two are also congruent, we can say that 5y minus 4 equals y plus 12. We're going to subtract y on both sides. We get 4y minus 4 equals 12. I add the 4, and I get 4y is equal to 16, y equals to 4. Now we're going to solve for x by doing 3x minus 5 is equal to 4 plus 12. So 3x minus 5 is equal to 16, plus 5 plus 5, 3x is equal to 21, divide by 3, and we get that x is equal to 7. Now, side, 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 or SSS congruence theorem is if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. That means that with the tick marks, you have one tick mark equals to one tick mark, 2 to 2, and 3 to 3. That means all of the sides of the triangle are written as congruent to another triangle. Decide whether the congruent statement is true. Explain your reasoning. So we go from D to F. That's 2 tick marks. F to G, that's 3 tick marks. And G to D, that is 1 tick mark. We go from H to J, that's 2 tick marks. J to K, that's 3 tick marks. And K to H, that's 1 tick mark. Now, because we are going in the right order, as 2, 3, 1, 2, 3, 1 for the tick marks, we can say that this is a true statement by the side, side, side theorem. Again, they're asking the same thing. Tell whether the congruent statement is true and explain your reasoning. We have A to C is 9, C to B is 7, and B to A is 3. C to A is 9, A to D is 7, and D to C is 4. Now, this is a false statement because this 3 and this 4 should have been congruent. Since they are not, it is not a true statement. Therefore, the triangles are not congruent. Decide whether the congruent statement is true and explain your reasoning. Q to P, 2 tick marks. P to T is 3 tick marks, and then 1 tick mark from T to Q. RS is 2 tick marks. ST is 3. And TR is 1. Again, 2, 3, 1, 2, 3, 1 tick marks. We're going in the right order, therefore this is true by the side, side, side theorem. Now explain why the bench with the diagonal support is stable while the other one without the support can collapse. You notice there's 1, 2, 3, 4, 5 beams, and here there's only 4. Now that fifth beam, which is this diagonal, creates two identical triangles right here, which is making them congruent. Therefore, the weight distribute is a lot better and it can support more. Now, parts of the right triangle, two legs and a hypotenuse. The hypotenuse is always across the biggest angle of the triangle. If you have another triangle like this with that's not a right triangle, the hypotenuse is still going to be across it. So that is always true no matter the triangle. For a right triangle, it's always going to be across from the 90-degree angle. The HL theorem is if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the two triangles are congruent. Now the keywords right here are right triangle. For the HL theorem, you could have two triangles right here, and they tell you one leg is congruent, and they tell us the hypotenuse is congruent. Then you're able to say that that is congruent by the HL theorem. But it doesn't matter what leg they give us. We could also have the red leg with the hypotenuse, and it will still be a HL theorem true triangle because we can equal them to each other as they follow the HL theorem. I'm going to do for this example this one in red and this one in black. So triangle JKL has vertices at -3, 2, at 0, -2, and at -3, -8. Now that one's not there, so I'm just going to put it down here. Sorry, that's not in the right place. Right here. Now we can tell this is a 90-degree angle because of the way the triangle is placed. RST has the vertices of 10, 0, 10, -3, and 4, 0. So again, right here, we can tell this is a 90-degree angle. So 90-degree, check. The leg is the leg congruent. 1, 2, 3. 1, 2, 3, yes. And then the hypotenuse. The only way you can figure this out is by using the distance formula. So the distance formula is x2 minus x1 squared plus y2 minus y1 squared, all of that under the square root. Now the distance for the red triangle, we're going to use the points K and L. I worked it out. I'm going to plug in the points, but I worked it out previously. So 0 minus -3 squared plus -2 plus 8 squared. That is 3 squared plus 6 squared. So 9 plus 36 is the root 45 for that one. And then the distance for the other one, again, we're going to plug it in. We're going to use, this is R, this is S. We're going to use ST. So 10 minus 4 squared and -3 minus 0 squared, all that under the square root. 6 squared plus -3 squared. 36 plus 9, that is still the square root of 45. So the hypotenuse is also congruent, therefore it is true by the HL theorem. Is there enough given information to prove the triangles are congruent? If there is, state that the postulate or the theorem. So the triangle that we have to find is FGH and HJK. Now, I'm going to highlight them. FG goes with HJ. GH goes with JK. And then the hypotenuse is the other one. Now, again, let's go through the checklist. 90 degree? Yes. The same leg. It's in the green. Leg. Amazing, they're both marked. Yes. Hypotenuse. It is given with 2 tick marks. It's given with 2 tick marks. Yes, across from the 90. Across from the 90. Amazing. All the 3 requirements are met. So this is true. It does have enough information by the HL theorem. And lastly, use the information in the diagram to prove ABC is congruent to DCB. Now, we learned earlier in a few chapters that that middle line that I just marked is a reflexive property, so we can say it's congruent. Now, this is a hypotenuse, this is a hypotenuse, therefore the one we just marked is the leg. Do both triangles have a 90 degree? Yes, they do. Do both triangles have a leg? Yes, they do. It's the one we just marked. And do both triangles have the hypotenuse? Yes, they do. So we proved that those two triangles are congruent by the HL theorem. You guys do have homework. Please make sure you do it. And that's it for today. This lesson.